So in this video I will show you how to check for slab deflection in ETABS for a real model. I have sent a .e2k file to check the deflection for your practice through your Google Classroom. So what you need to do is go to File, Import ETABS.e2k text file. Yes, this is my .e2k file. You just open it. You just close the 3D view. Go to Plan. You select roof floor. So I have roof floor plan. This is my actual model. You just run the analysis. It will ask you to save deflection check file. You save. Wait until it finishes the analysis. Yes, it completed analysis. So go to display deformed shape combination. In load combination, you should select dead load plus slide load. Again, draw contour on objects. You should have UZ direction. Apply. OK. Okay. I will check the mesh size. So analyze automatic mesh settings for floors. So I will decrease this to 0.3. Okay, let it be 0.5 only. Okay, run the analysis. Now I am in roof floor. So Z value it is 8.15 meter. From ground it is 8.15 meter, my roof level. So go to display deformed shape combination, live load plus dead load, apply, close. So this is your first diagram. So you create another view, add new window. So in ETABS you can create multiple windows. So in the first view I have my plan model. In the second view I have deflected shape. So I will remove this grids. I will remove this grid lines. Okay. Now if you see here in this first figure, which slab is more critical for deflection? So I think this slab will be the more critical for deflection, which is having bigger size. So you remember, for slabs we check deflection, at service limit states, limit states. We design our slabs for flexure and shear for ultimate limit state. Ultimate limit state. So as per IS code, the limiting value or permissible deflection, it is span divided by 350 for slabs having partition walls and floor finishes. Okay, so this is as per IS code, IS 456 2000. So L by span by 350 when having flooring and partition walls. See, so this is your deflected shape. So it is a displacement at load combination dead load plus live load. So the unit deflection unit, it is in millimeter. So here I will remove this. If you see here, if you see this contour, first this color, it is in magenta color, which represent higher deflection. Which represents higher deflection. Next, here it is blue color region, which represent very low deflection. From this contour, now we can say that which slab is critical for your deflection check. I think this slab is critical. So here in the undeformed shape, so this slab will be the critical for a deflection check. So for deflection check, we always consider shorter span. So in this slab, so this span, it is shorter span, and this will be your longer span. How to check the length of the slab, or length of short span and the length of long span? So you just click on this joint or this column. At the right corner, you will see, you just click on this joint. So here at the right corner, you just click on this joint, your right corner, you will see x value as 6.975. so here x value is 6.975. so x coordinate is 6.975. similarly, here the x coordinate is 6.975. similarly, you place your mouse cursor on this joint. So here x value is 11.7297. so what is the x value? Here 11.7297. now you can check the span. So it is 11.7297 minus 6.975. so it is 4.75. so this span, it is 4.75 meter. This is short span. This is your short span. How to check this long span? Long span, you just place your mouse cursor on this joint. You note down the y coordinate. Y coordinate is 14.26. so here y coordinate is 14.26. next you place your cursor on this joint. So your y coordinate is 8.2595. so here y coordinate is 8.2595. You deduct these two values, you will get the span. so here it is 14.26 minus 8.2595. so it is 6 meter. so this long span it is 6 meter. so we check deflection for short span. so what is the permissible deflection here? Permissible deflection is span by 350. so your span is 4.75 meter. You convert this to millimeter, multiplied by 1000 divided by 350. so you will get permissible deflection as 13.75 millimeter. so this is your permissible deflection. so how to check your actual deflection? From your ETABS model. How to check the actual deflection? You go to deflected shape. So display deformed shape combination. You should have dead load plus live load. Apply. OK. so which is the critical? so this slab. so this is your critical slab for deflection. so where there is a magenta color, you place your cursor. I think it is minus 5.7. So I am in the roof floor. Yes, it is minus 5.7. So your actual deflection is minus 5.7 millimeter. Minus means it is in gravity direction. We check deflection along gravity downward direction. Okay, so minus 5.7. So your ETAP's deflection is 5.7 millimeters. You compare these two values. You compare these two, your permissible deflection and your actual deflection. So in this case, your actual deflection which is less than your permissible deflection. So actual deflection is 5.7, which is less than your permissible deflection. It is 13.75. How it is 13.75? It is as per code, span divided by 350. So here actual deflection is less than your permissible deflection. Hence we can say this slab is safe in deflection check. Hence you can say this slab is safe in deflection check. This is how you need to conduct deflection check for slabs in ETAPS.